So I just did a video where I explained how to solve these logarithmic equations, and I think my video is pretty deceptive because it makes it look pretty easy, but there are way harder problems in your homework, so I'm going to show a little bit of a harder one. I'm going to do number 14 from your homework. If I do number 14 from your homework, that one says log base 3 of x squared minus 3 equals log base 3 of 2 plus log base 3 of x. So, step 1, I isolate a log. Did it. Isolate a log. Already did. Step 2 is cancel out that log by using exponents, or in the last video I showed how it kind of also is by using the loop. I can do that right now, and I will do that for you to show you what it's like if you didn't think of what I'm about to point out. But I'm going to also, before I do that, I'm going to condense this down. It's going to be easier to work with this all as a single thing rather than a separate. I'm going to rewrite it using my log properties as log base 3. Log plus a log turns into multiplication. I'm going to make it log base 3 of 2 times x, or log base 3 of 2x. And the other side is still log base 3 of x squared minus 3. That's just going to be nicer to work with, because now I can look at this and I can say, oh, x squared minus 3 is 2x. The thing I'm doing behind the scenes to get to this, I'm just looking at this and saying, oh, if log base 3 of this equals log base 3 of this, this must be that. The algebraic explanation for what I'm doing is I'm doing 3 to this power, 3 to this power. 3 to the log base 3 of x squared minus 3 makes x squared minus 3. That's one of those things that cancels. Why it cancels is that this says 3 to what power makes x squared minus 3. This comes out to whatever number that when I raise 3 to that power, it makes x squared minus 3. Now I raise 3 to that power, it's going to make x squared minus 3. Same on this side. Cancels, makes 2x. It's gone from algebra 2 problem, looks pretty scary, algebra 1 problem that is not bad at all. I'm going to solve it by moving everything to one side, and then factoring or completing the square or quadratic formula or square root if it's set up that way, but it's not going to be. These are going to be factor problems. I factor, get x minus 3, x plus 1 equals 0, so x equals 3, or x equals negative 1, and I'm done, right? I did step 1, I did step 2. Not done because there's a step 3. Step 3 is check for extraneous. I have to plug these back in, make sure neither of them are extraneous. If I plug them back into my original equation, if I check for extraneous with these problems, all you really need to do is check to make sure you're not doing log of a negative number. You cannot do log of a negative number. It doesn't make sense, it doesn't compute. If I plug back in 3, I get log base 3 of 3 squared is 9, minus 3 is 6, log base 3 is 6, I'm allowed to do that. If I plug 3 into over here, log base 3 of 3, I know that's actually 1, and it's not a log of a negative, that's all I'm really checking, but I happen to know it's 1. If I plug in 3, I don't get any logs of negatives, so 3 is good, I like this answer. X minus 1, if I plug in x equals negative 1, if I plug in x equals negative 1, this becomes log base 3 of negative 1 squared is 1, minus 3 is negative 2. If I plug in x equals negative 1, I end up with a log base 3 of negative 2, which means it's a garbage answer. I do not include that when I give the answers. On the quiz or test, if you raise your hand and you say, do I write the extraneous solutions? I'm going to laugh at you. You don't need to ask that. They're extraneous. They're not correct, so don't write them. I won't actually laugh at you. I'm not that person. 3 is our solution. I said that I would do this. Maybe you didn't think to do that move. I said I would do it like that, so I will do it like that. But maybe this video was enough that already you're like, oh, I'm good. I don't need to watch anymore. But if you want to know what happens when you try to do that, when you don't think to condense it, I have this, and if I didn't condense it, then I'm thinking to myself now, I'm going to do 3 to this side and 3 to this side. I'm going to do 3 2v log base 3 of x squared minus 3 equals 3 to the log base 3 of 2 log base 3 of x. And from here, this side cancels. X squared minus 3 equals, here at this point, maybe I think to combine the logs using my product property, I can condense it down. Or maybe I think 3 to the a plus b is 3 to the a times a to the b, so maybe I write it as 3 to the log base 3 of 2 times 3 to the log base 3 of x. And then I think to myself, well, that means x squared minus 3 equals 3 to the log base 3 of 2, that cancels into 2. 3 to the log base 3 of x cancels into x. So I get x squared minus 3 equals 2x, which is what I had before. It's kind of an all roads lead to Rome type deal. Just this was not necessarily as friendly as this. But it's the same thing. I get the same answers. One of them is going to be right, which is x equals 3. One of them is going to be extraneous. That was x equals negative 1. Those are my solutions. Or solution. X equals 3 is my solution.